This is Tim Young with Elevate Software, and in this video I'll be discussing how to configure and start the Elevate Web Builder 3 web server. So, which web servers are provided with the product? There is the internal web server that is actually embedded in the IDE. It's compiled into the IDE, so its actual location is part of the IDE itself, or the IDE binary, which can be found at the location indicated here. And then the configuration file for the IDE is located here. It is a user-specific ini file, so it's going to be located in the subdirectory under users that corresponds to the current user account that you're running under. There's also a 32-bit command line web server. This is for development purposes. It's a 32-bit Windows console application, so it can be just run on demand. There's a start menu entry for it that's created during installation. However, it does actually use the standard location for the EWB server ini file, which is in the program data folder. And what you can do by just launching the 32-bit command line web server is, if it doesn't find the ewbsrvr.ini file in this location, it will go ahead and write one out. So it's also very good for if you don't have anything set up yet for the configuration. If you just run the 32-bit command line web server real quick, it will go ahead and create that file with the default values for the ini file settings. In addition to those two, there is also a Windows service that is available in two forms. It's available in a 32-bit form and a 64-bit form, and you can see that these are located in corresponding directories to indicate whether they're Win32 or Win64. Both of them also do use that standard program data folder location for the ewbsrvr.ini file. That is the standard location for that. That's where the binaries, or the server binaries, will look for that configuration data. All right, moving on. Okay. So the default web server directory structure, the internal web server embedded in the IDE, its locations or the server directories for it are going to be located in the same directory as the EWB IDE .ini file, that is in the user specific folder, but there's a subdirectory underneath it called server, and that is where all of the server directories are going to be created for the embedded server. For the external web servers, both command line and the Windows services, the location for the server directories is going to be the basically the root folder for the program data folder. So, what do these server directories look like? So you have the root server directory, which is effectively the directory that I just indicated. That is where the web server database file is stored. Its name is ewbsrvr.db. This is a custom database format. Underneath it, you have the content folder. This is where you have your static content, your HTML, JavaScript, images, video. This, for example, is where EWB client browser applications would be deployed. There can be subdirectories underneath the content directory. It's just that the content folder is the root folder for all content related to the web server. The applications folder is for the server applications. Again, that can have subfolders. The modules folder is for the native web server modules, and that can also have subdirectories. And then you have your logs folder, which is going to have two subdirectories by default. One is called request. That is where the HTTP request logs are stored. They are segmented or named according to the day, month, and year. And those are in a CSV format. And then you have the system audit logs. Those are also named in a day, month, year format, and are in a JSON format, a somewhat custom JSON format. So these are the web server database settings. The web server database directory setting, and just to point out, these the names that are highlighted in blue are the actual names of the setting in the INI file. So you can use these in the slides to correspond to the INI file if you want to cross-reference the two. So the web server database directory determines where the EWB SRVR db.db web server database is stored. The web server max database write delay setting determines how long in seconds the web server will wait after an update before writing any updates to the database. The default is 2 seconds. All the database writes are atomic. Writes are first durably written to a transaction log, and then the database is subsequently updated. The web server will automatically recover from a database update failure during startup and basically roll back any incomplete updates. So the web server will store each user password in that database as a hash. It's going to be a combination of a cryptographically secure random value, otherwise known as a salt, plus the password. The web server password salt length setting will determine the length of the salt value, and the default is 16 characters, which for most purposes should be fine. The web server password hash type setting will determine how the salt plus password hash is generated, with 0 being an SHA-2 256 hash and 1 being an SHA-2 512 hash, and the default is obviously 0 for the SHA-256 hash. So these are the directory settings. This is where you actually specify the directories that we already discussed in a couple slides back. The content directory, this is again static content, HTML files, images, whatever you want to deploy in terms of static content. In addition to the content directory setting, the web server also has a default document setting that specifies the default static HTML file to use if the root URL path is referenced without specifying a file name. And this only applies to header get HTTP requests. The default is blank, but say you wanted to say, for example, if we use localhost as an example, localhost, say you're referring localhost as the domain, and you don't specify a home.html or an index.html file or something like that, this document setting here is what will be served up. And of course, that file does have to actually exist in the content directory, otherwise it will not be able to be served up. So effectively, that gives you a way to have a default HTML file be displayed in the case of where a user doesn't actually specify one. That can also be an Elevate Web Builder browser application also, if you wanted to be that to be the case. The application directory, this is where the server applications are deployed. By default, again, that is applications. Module directory is where the native web server modules are deployed. That is also called modules by default. The log directory is where the web server logs are located. That is called logs by default. In addition to the log directory setting, there's also a request log setting that determines whether HTTP request logging is enabled. It is by default. In addition, there's also a web server logging setting that determines whether the system logging or audit trail is enabled, and that is also turned on by default. So in terms of starting up the web server has several settings that apply to startup. The web server can be bound to one or more IP addresses using the IP address setting. The default is blank, in which case it will bind to all local network interface addresses. If you specify an address, it will only bind to that particular address, which is good if you, for example, only want to listen to incoming requests on a LAN and not any external requests coming from outside the network. The web server is bound to 2 ports. One is the insecure HTTP port, and that defaults to port 80, and the secure HTTPS secure port setting, which defaults to 443. Both of these ports must be available, or the web server won't be able to successfully start. And you'll see this, like if you are running the web server as a service, you try to start the service. If these ports aren't set correctly, what will happen is you'll see the service start up and then it'll promptly shut down. And then you have to go look in the Windows event log to see what the error message is. But the error message will be then that it can't access that or can't listen on that particular port because it's already in use. The web server also has a setting called redirect to secure that will ensure that any requests to the HTTP port are redirected automatically to the HTTPS port with a 301 moved permanently status return to the request to the non-secure port. This is handy in situations where you don't want any normal connections to the web server. You want them always to be HTTPS connections, and this is a very easy way of doing that without having to do any kind of special coding. Continuing, the web server timeout setting will determine how long the web server will keep a connection open while it's waiting on any subsequent requests. It does try to use long standing connections, so it'll try to keep connections open and reuse those connections over and over again. The default is 30 seconds, so it'll after an initial request comes in, it will keep the connection open for 30 seconds. If it doesn't hear back from the client in terms of any more requests, it'll go ahead and close down the connection. The max request size setting will determine the maximum number of raw bytes that can be received in a request. The important part here is raw bytes, because obviously when you're talking about encodings and different types of content, the number of bytes can depend upon the type of encoding. The default is around 64 megs, which is usually plenty, but you can up that value if you'd like. Usually the general idea is you don't want any given one request to be particularly large. So if you're uploading a very large file, for example, you would probably do the same technique that the Elevate Web Builder web server does for deployment purposes when you're deploying an application or any kind of arbitrary file, and that it will break up the upload into multiple chunks. So it's only uploading small 16 meg chunks at a time, so it never actually exceeds the max request size. The authorized addresses setting is a common delimited list of IP addresses that are permitted to connect to the web server. The default is all addresses, which is what the asterisk represents. You can use wildcards in the addresses, and they can be present anywhere, so you can have multiple wildcards, for example. The corollary to the allowed addresses is the blocked addresses, which is also a common delimited list of IP addresses that are not permitted to connect to the web server, and the default is blank. So all addresses by default are allowed to connect to the web server. And again, these are addresses from the perspective of the web server. The web server thread cache size setting will determine how many threads can be cached for the purpose of servicing connections. The default is 128 threads. You can increase this as high as you want, but just keep in mind that there's also the maximum threads setting that determines how many threads in total can be created concurrently for servicing connections before the web server will just flat out refuse the connection and not instantiate any more threads. The default is 2048. I suspect in most cases you're not going to be exceeding that. If you do, then you probably are going to need to go to a more scalable web server environment. So as far as routes, now again, these are web server routes from the perspective of the client. So this would be what you would use, for example, if you're typing a path in the browser, if you're trying to access something on the web server. So the origin or the root, the origin is of course going to be the protocol, which is HTTP or HTTPS. You'll have 2 forward slashes. You'll have the domain, which can be, for example, www.elevatesoft.com or localhost. And then you optionally have a colon and then the port number. If you're using the standard ports, whether it's port 80 for insecure requests or port 443 for secure requests, you don't need to specify the port. You only need to specify the port if it's different than those two standard ports. So the root path is, again, the content path, the static content, and it corresponds back to the content folder that you configured a little bit earlier. So any time that the user refers to the root path and specifies an actual file name, then it will actually go and try to load that file or return that file from the content directory. And again, if they don't specify a file name, then you're going to see the web server try to load the default document if it's been specified, or return the default document if it's been specified. If not, it will simply return a 404. So underneath the root path, you have several different sub paths. These are the keep alive path. This is simply just a kind of a nonsense route that just allows you to send requests to this particular path, and it will keep alive the session. And you would do the keep alive request as a post request. That's just an arbitrary distinction, or it's just an arbitrary selection. It could have easily been a get also, but post makes a little bit more sense. And that will take an already authenticated session and then effectively re-up it. So you could, for example, in an EWB client browser application, have a timer set to go and just automatically re-up the session every now and again by just sending a server request to this particular path. The authentication path is for performing session authentication requests. These are RPC requests. I'm not going to get into the finer details of these API routes. That will come in a subsequent video, but just be rest assured that under each one of these, authentication doesn't have a lot, but for example, under administration, there is a lot of different API calls that can be made under there. Same with databases. So it's not just these routes that are used. So the administration route is also the same situation. It's an RPC style API underneath that path. The databases path is for databases and data sets. It is actually a RESTful API, so it works more in a REST-oriented manner. The server applications path is used to access server applications, and effectively it's going to be the applications path plus the name of the server application itself, and the name is assigned when you actually install this server application. So the actual file name of the server application doesn't necessarily need to correspond to what you would use necessarily here in the path name for the server application. Very similarly, the modules path works in a similar fashion. The native web server modules would be referenced using modules and then / and then the name of the web server module that was given to the module when it was installed. Again, not necessarily the same as the name of the file name that represents the module. And then finally, you have a debugger path. This is used exclusively by the IDE. I doubt very much it would ever be used by any other type of client outside of the context of the IDE, but it's used for remote debugging in the IDE, and has a set of probably about 6 or 7 API calls that deal with debugging. So that's how the routes are constructed by default. And here are the settings for those various resource names. And how they appear in the INI file. You have the keep it alive resource name, you have the authentication resource name, administration resource name, databases, applications, modules, and debugger, with all the defaults listed there. So how are these sessions handled in terms of the web server, in terms of how the requests are coming in? So requests to the root URL path do not require a session, and they don't require authentication if the request is for an existing static content file. So if the user tries to reference an existing file in the root path via a head or get request, then the web server is not going to try to instantiate a session or require that that session be authenticated. The two are pretty much go hand in hand. If you have a session, it needs to be authenticated in order to make any calls using that session. Requests to any other URL paths will require a session and an authentication, and this obviously will apply to all types of requests. So head, get, post, put, patch, and delete requests are all permitted, but they would require a session to be instantiated and be authenticated. Now, the sessions are only created during an authentication request and are removed immediately if the authentication request fails. So there really isn't any way to execute a denial of service by trying to overload the web server with sessions that get created and then never disposed of. And one thing to point out too, the keep alive requests, I think I already mentioned this, but the keep alive requests also need to be authenticated. You can't execute a keep alive request from an unauthenticated or against an unauthenticated session. So the session flow. So the way it works is very simple. You have an authentication request come in. If the authentication request succeeds, it's a valid user. They're not locked out, anything like that. You can then a session ID is then created, and the session ID, or excuse me, the session is created. The session ID is then returned as a cookie when the authentication succeeds, and then subsequently the cookie will be passed back to the server in any subsequent requests until the session is either de-authenticated, which is an actual manual call that you can perform, or the session has expired and been removed. At which case you're back to point one, where you would need to re-authenticate, and a new session ID would be created and a new cookie returned. So the session settings in the web server. The sessions are handled using an HTTP only cookie, and it has a cryptographically secure random session ID enclosed in it. You can use the web server's redirect to secure setting to ensure that the sessions are always established using secure connections. Now, very briefly, what is an HTTP only cookie? What it is, it's a way to avoid certain types of attacks on your web applications by hiding the cookie from any JavaScript. So it's impossible for any JavaScript running in the browser to see the cookie or to grab the session ID. It will simply never be visible to any JavaScript. So that prevents the session ID from being hijacked and being used for nefarious purposes. The web server's session ID length setting will determine the length of the random session ID. By default, it's 32 characters. That should be plenty for most needs, but you can increase the size if you want something a little more unique. The web server session expiration setting will determine in seconds how long a session will be kept in the web server without any activity. The default is 1800 seconds or 30 minutes. Again, you can use a timer and an EWB client application to go ahead and re-up a session by simply sending a request to the keep alive URL path, in which case that will reset that session back to whatever the expiration time setting is here. The max authentication attempts setting will determine how many authentication attempts can be made for a user before the user is locked out. The default is 10. If they do exceed the 10 authentication attempts, the authentication lockout time setting will now kick in, or will then kick in, and that will determine how long in seconds the user is locked out after exceeding that maximum number of authentication attempts. The default is 300 seconds or 5 minutes. And the administrator can see information about whether a user is locked out and when they will be allowed back in. Okay, so one of the more important parts of setting up the web server is getting the certificates correct. And on Windows, certificates are stored in sets of certificate stores. There are separate sets of certificate stores for each machine user, as well as a global set of certificate stores for the entire machine. Certificates can be managed in a few different ways. They can be managed programmatically using Windows API calls. They can be programmatically managed using Windows PowerShell scripts, which are very nice. Or they can be managed interactively using the Microsoft Management Console with the certificates snap-in. And with the Microsoft Management Console, which is mmc.exe, you have to actually load two different snap-ins. You have to load a snap-in first for the current user stores, and then load in a second snap-in for the local machine stores. So I'll show you real quick how that works. So let me just pop out of the slide here. So if you just go to Start menu and we type in MMC, I'll show you. You can do File and then Add and Remove Snap-in, and we want the certificate snap-in. So just Add, and we're going to add the first one for the current user account. Then we're going to say Add again, and then this one we're going to set for the computer account, and we're just going to keep this as the local machine. So click on OK. You can see now these are all the certificate stores for both the current user and the local computer. The one that we're always interested in is the personal certificate store, and that goes for both the local computer and the current user. And here you can see the local host certificate that we actually create for you, which we're going to cover in just a second. But this will allow you to see all those. You can actually import new certificates into here. So if you get a certificate issued by a certificate authority like Komodo, you would import it into this store. Depending on whether you're using the local development web server or whether you're using an actual Windows service. If you were using a Windows service, you would want to import any certificates into the local computer store. Otherwise, they won't be accessible to the service. And if you were just doing development under your user account, you would import those into your personal certificate store for the current user. And as you can see, that's what we do with the local host certificate here. So minimize that and move on to the next one. Okay, so when you're dealing with the IDE, when you first start up the IDE after installing the Elevate Web Builder product, you're going to see that you're going to get an error message when it tries to start the internal web server that runs in the IDE. It's going to tell you that it can't find a localhost certificate, and you need to have one installed. Otherwise, you won't be able to start the internal web server. So first and foremost, this localhost certificate should only be used for development purposes. It's a self-signed certificate. So it's not valid out of the context of development. So do not use it for any other purposes other than that. None of the browsers would accept it anyways, but it's just fair warning on that. The internal web server that's embedded in the IDE won't start properly without this localhost certificate installed, and you're going to see an error during startup if it's not present. So how do you get this localhost certificate created? We include a special utility with Elevate Web Builder called the EWB Cert utility, which will automate the entire process of creating the localhost certificate that you need to be able to do development in the IDE. So if you just type in EWB Cert and don't give it any parameters, you will see something similar to what you see here, where it will tell you what the command line usage is. The way it works is you specify the utility name, then you give it the certificate name. Optionally, you can give it the certificate store name, and also optionally, you can give it the certificate store type. But most of the time, you will just use the defaults for both of those for development purposes. And finally, there's two other parameters. There's -C for create, and then there's -R for remove. So again, the certificate store name is going to default to the My Store. That's the same as the personal store that you just saw. in the Microsoft Management Console. The certificate store type defaults to current user, so you don't normally need to specify that because we're usually only interested in setting the certificate for the current user. So as you can see, the command create the localhost certificate for the IDE is EWB cert space localhost space -c, and if you wanted to remove the localhost certificate, you can type in EWB cert space localhost space -r, and that's really all you need to do. Internally, the EWB cert utility uses the Windows API to actually do all the certificate creation. And effectively what it does do is it effectively creates a self-signed certificate as a root certificate, as a Elevate Web Builder root certificate, and then uses this root certificate to sign a local host certificate that's in the personal or my store. It has to do it that way because of the way that browsers expect to see the certificate chain. If you don't do it that way, certain browsers will balk at these certificates and not allow you to use them. So that prevents, if you had the Elevate Web Builder IDE running, it would prevent you from using an external browser to try to load applications against localhost, which is it's not ideal. You want to be able to do that for testing purposes. So once you've got your certificates created, these are the settings that allow you to specify those that certificate information in the web server INI file. So you have the certificate name setting that determines the name of the installed certificate that will be used for the HTTPS connections. The default is blank, but for example, if you were running the external command line web server for development purposes, you could specify this as localhost, and that would work. The certificate store name setting will determine the name of the certificate store where the certificate is installed. It also defaults to the My Store, which is again the same as the personal store in the MMC utility. And then the certificate store type will correspond to 0 for current user and then 1 for the local machine store. And again, that defaults to current user or 0. Miscellaneous settings. There are basically only one miscellaneous setting for the web server, and that is the Enable Cross-Origin Resources setting. And what this does is it determines whether the web server will respond to requests that are cross-origin and whether respond to them affirmatively and allow them to go through. What happens is if, for example, you were to load a application from, say, localhost, and then you tried to actually execute server requests to, say, for example, www.elevatesoft.com, the browser would only allow that if the web server that is servicing www.elevatesoft.com allowed such a cross-origin resource request to occur. The default for this is 0, but if you do enable it, it would allow you to service such requests. And in most cases, you don't want to enable unless you actually know what you're wanting and whether you actually know that you need it. So this is an example of a sample EWB SRVR INI file, and it pretty much has all the settings that you can see that correspond to what we've already covered, but it's nice to see it in this form just so you can get an idea of what you're looking at. And again, all of the settings marked in blue in the slides correspond to the settings that you see right in front of you here. All right, so starting up the web server, there are two separate settings that you can specify when you start the web server, and this corresponds to, or this actually is the case for both the command line web server and the Windows service web servers. And the two parameters are the name parameter and the DESC or description parameter. And what specifying a server name does is it allows you to run multiple instances of the EWB SRVR binary, but have each one of those instances use a different set of INI settings based upon the server name that you give it. So say, for example, you had a server that you wanted to be listening on one set of ports, port 80 and 443, and then you had a server that you wanted to listen to on a different set of ports or a different set of IP addresses. You could set up those up in the INI file by simply just setting up sections that have this structure of server underscore and then the name of the server. And then you can specify the /name parameter when you start the server, and it will grab the settings from that section of the INI file. The default is just server with no underscore and no server name afterwards. So that is effectively the global settings when you don't specify a server name. There's no limit to the number of server instances that you can start, but each instance must use a different server name, and they must use a different set of secure and insecure ports. So this is pretty much how you would specify the or start up the 32-bit command line web server, and you can see what the output looks like when you were to do so. In this case, I think it was started up without specifying a name or anything, so it's going to be using the default name of EWB SRVR with a default description of the Elevate Web Builder 3 web server. It does give you a little information on what the settings are in terms of the directories, and also whether logging is enabled or not, and also what ports it's listening to. And once you start it, as you can see, you can press enter and it'll go ahead and close it down, which is one of the reasons why the command line web server is pretty much only good for development purposes. It's not really useful in any other context. Now, the Windows services require a little bit more work to get up and running because of their Windows services. The first thing you need to do is install it as a Windows service. So from the command line to install either the 32-bit or the 64-bit web server, you would specify EWB SRVR. You can optionally specify name and description, and then /install. And then you would also have the option of specifying /silent, which will prevent any dialog boxes from being displayed, indicating that it was successful or not successful in terms of the Windows server's installation. To uninstall either the 32-bit or 64-bit web server, you would basically do the same thing, but instead of install, you would use /uninstall. Now, administrator privileges are required here, otherwise you'll get a Windows error 5 or access denied error. So just make sure that if you're running this from a command line, that you are running it from an administrator command line. Also, if you do specify a server name when you're installing the Windows service, what will happen is the web server will go ahead and write that server name out as part of the startup command line that's registered or that's added to the registry in Windows. So that way that service will always start up successfully and use the proper service name, which is important when you have multiple server instances. And that's pretty much it. So it's a lot of ground to cover. We're going to be doing a subsequent video on the architecture of the web server in terms of the server applications, in terms of administration, and many other things. So if you have any questions on what we just covered, please feel free to ask away in the comments section below. But look forward to the server administration video and the video about how to create server applications. And those will be coming soon, probably within the next week. As always, we appreciate your time, and have a great day.